Now, in the main video we covered the basic complex cube, and as some of you might have noticed, we covered those imaginary pieces which only have one type of sticker. The astute among you may have asked whether or not we could define pieces with repeated stickers, as since the pieces are imaginary anyway, we don't really have to bother with actually constructing them. Well, you'd be correct in your reasoning, because it's reasonably easy to define pieces, and all we have to do is use this permutation scheme we defined in the video. So, for example, we can pick a piece at random, say UUR, and apply an R move to it. Consulting the chart, we find that this must move to BBR, whereas if we take UUU, we find that if we apply an R, L, F, whatever, it remains UUU no matter what move you apply to it. Now, this leads to an interesting point that the pieces which have repeated stickers appear to act in the same way as pieces which have the same number of distinct stickers. So, if a piece only has one type of sticker, like the UUU piece, it behaves as if it was a center, i.e. it doesn't really get affected by any move that we have. Whereas if a piece has two distinct sticker types, it acts like it was an edge. So this is the main reason why I left this out of the main video, because they're not terribly interesting, because they just behave more or less exactly how the imaginary pieces would, and I wanted to keep that video shorter than it otherwise would have been. And one final point we can make about them is that there must be 6 choose 2 plus 6, which is 21 edges in total if we include these pieces, and 6 choose 3 plus 6 squared equals, plus 6 equals 62 different types of corners. So that's it for this footnote. In the next footnote we'll look at one other alternative definition of the complex cube, and that will be alternative definitions of moves. So I will see you guys later and catch you in the next footnote.